Okay, let's take a look at our first probability question. You ask a friend to think of a number between 4 and 12, and we're including those. What is the probability he will choose 8? So we are looking for the probability of 8. Well, I'm going to start by listing out my sample space, my total number of things that could happen. So he could guess 4, 5, 6, 7, 8, 9, 10, 11, or 12. Any of those are perfectly valid outcomes because those are all of the numbers between 4 and 12 included. My sample space has 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. If I look at my sample space, I only have 1, 8. So when I'm talking about the probability of guessing an 8, we said earlier probability was the number of ways our event can happen. Well, I can only choose 1, 8 divided by the total things that could happen, or our sample space. Well, my sample space had 9 outcomes in it. So the probability of guessing an 8 would be 1 out of 9. For probability, you can leave that as a fraction or you can convert it to a decimal. I am going to leave it as that fraction. 2, you roll a fair 6-sided die. What is the probability you roll a 1? So when I roll a die, I could roll a 1, or a 2, or a 3, or a 4, or 5 or 6. The one I want is right there. So the probability of rolling a 1, well, I only have 1 out of 6 total things that could happen. So my probability of rolling a 1 is 1/6. Don't think too hard. This one is a little bit different. We have 5 blue Powerades, 4 reds, and 3 orange. I don't have an orange pen. This is close enough. What is the probability you stick your hand in and blindly choose blue? So we want probability of blue. Well, we need to take a look at our sample space. Our sample space has 5 blue ones, 4 red ones, and 3 orange ones. I want the number of ways I can pick a blue one. I have 5 blue ones to choose from. Not with the highlighter, Graham, get your life together. So I have 5 possible blue ones. Out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total drinks. So I have a 5 out of 12 chance of choosing a blue one. Now, quick little side note. I guess I can go ahead and stick it up here. Under probability, make sure you reduce your fractions. If you're going to use fractions instead of decimals, make sure they're reduced. And also, let's talk really quickly about the possible values for probability. When we talk about probability, 0 is the smallest probability you could have, and 1 is the largest. A probability of 0 means absolutely not. A probability of 1 means absolutely is. So 0 is the probability of it raining elephants at noon today. 1 is the probability of death and taxes occurring in your life. If you get a probability of 5 or 1.7 or -3 or 4.9, you did something wrong. Your probability value should always be between 0 and 1 inclusive. So back to our regularly scheduled programming, a magician showed a magic card trick where he picked one card from a standard deck. Determine the probability that the card will be a black queen. Now, I don't know how much you know about a deck of cards. Brief rundown. You have 52 cards total. 26 are red. 26 are black. Those 52 cards, like I just said, are broken into red and black. The other way they are broken down is into suits. So you get the red ones are diamonds and hearts. The black ones, I'm going to use blue because I don't have a black pen, are spades, and my spades always look a little weird, and the clubs. That is a really interesting looking club. Inside each one of these, you get an ace, a 2, 3, 4, 5, 6, 7, 8, 9, 10, and a jack, and a king, and a queen. For every single one of those, I'm not writing it out 4 times. You can figure it out. So we want a black queen. Well, we know we have a total of 52 cards we could pull out. So 52 total cards. When I look at these, I know I'm going to have a queen of spades and a queen of clubs. The only 2 other queens I have are the queen of hearts and the queen of diamonds. I want the black ones. So I have 2 black queens. Divided by 52 total cards, that is not a reduced fraction. So I'm going to pull out my handy dandy Desmos calculator and put in 2 over 52. And I get a probability of 1 out of 26. So here's our happy little spinner problem. A spinner is divided into equal parts. After the spinner is spun, the arrow points to one of the colors. Find the probability of spinning red or blue. Well, my total sample space, 1, 2, 3, 4, 5, 6. I have 6 total colors, 6 sections. I want red or blue. So here's my red one. There's my blue one. That's 2 sections. Out of 6 total sections. So I have a 1/3 probability of spinning a red or a blue. Now we're going to roll a die. What is the probability you roll a 9? Well, we talked about a die before. We said our sample space was 1, 2, 3, 4, 5, or 6. Do you see a 9 in there? I don't see a 9 in there. Well, if you don't see a 9 in our list of possibilities, that means the probability of rolling a 9 is a big fat 0. And that's okay. If you roll a die, what is the probability of rolling an even number? Well, I am going to get our sample space from right up here. I'm cheating a little bit and I'm totally fine with it. We have 6 total possibilities. Come on, we want an even number. Well, if it's been a while since you talked about even numbers, that means we're interested in a 2 or a 4 or a 6. That is 3 outcomes that we want out of 6 total. If I reduce my fraction, I get a probability of 1/2. We will pause there. We'll let that digest for a minute. And then we will continue our study of probability by looking at the fundamental principle of counting.